In section 10.1, we're looking at the definition of an nth root. So a square root, you can say b is a square root if b squared equals a. Anyway, for 1 through 3, we want to look at the square roots of these numbers. So what is the square root of 64? Basically what we're wanting to know. Now our calculator, we can do this in the calculator. There is a square root key, and let me show it to you here. So we just want to type in seconds, and then we can hit the square root key. See, it says x squared, but when you press second first, it lets you do the square root option. That's in the light blue up there. So we're going to put 64 in here and close the parentheses and press enter, and we get 8. Okay, now 8 is the answer, but there are actually two answers to this one, 8 and negative 8. The reason behind this is 8 squared means to multiply 8 by itself, right? And 8 times 8 is 64, which is 8's the square root of 64. But negative 8 squared is negative 8 times negative 8, and a negative times a negative is a positive 64 as well. So whenever you get that answer of 8, just know that you had to put negative 8 in there with it as well. Now, when we get to our second problem, and it's asking us to take the square root of negative 25. So I'm going to type this in my calculator, and it's going to give me an error message. Second square root negative 25. See how it gives us that error message? That's because there are no real valued squared roots of a negative number, and negative 25 is a negative number. Basically, when you're taking a square root, again, you're asking yourself, what two things can I multiply by itself to get this number? So what two things can I multiply by itself to get negative 25? Well, you can't multiply two things by itself. If it's 5, for instance, is the square root of 25. 5 and negative 5, and that's because 5 times 5 is 25, and negative 5 times negative 5 is 25. But you're never going to be able to multiply two numbers by itself and it give you a negative. So that's why our answer here is no real valued square roots. So when I'm taking the square root of 1 over 81, we're able to separate that root and take the root of the denominator and the root of the numerator. And the square root of 1 is 1 because 1 times 1 is 1, and the square root of 81 is 9. So we can say that this answer is positive 1 over 9 and negative 1 over 9. There is also a way to do this one in the calculator. Okay, I'm just going to press second and then square root of 1 divided by 81. Close the parentheses, press enter. We get this decimal. I'm going to press this second key. And this PRB key, which when you press second, is going to let you do the fraction decimal option. So 1/9. And again, when you're taking that square root, you know that your answer can be both positive and negative right there. So now we get into some notation for positive and negative square roots. I told you, whenever you take that root, that it could be positive or negative, the positive or negative version of that number. Well, the positive we call the positive square root of the number, and the negative we call the negative square root. And then the square root of 0 is 0. It's neither positive nor negative. So let's do some practice with these. It's not bad at all. What is the positive square root? Or in this case, it says principal square root of 121. And we can type that in our calculator, but it is 11. 11 squared is 121. So the square root of 121 is 11. Now, what is the negative square root of 121? And that is negative 11. So we're going to look at some more square roots. This decimal right here, you can type that into your calculator just like it is, and it gives you 0.5. And since it is already in decimal, since it started in decimal form, we can leave it in decimal form. You could also think of 0.25 being equal to 1/4. So if you took the square root of 1/4, that's the square root of 1 divided by the square root of 4, which is 1/2, which is equal to the 1/2 that we got right there, or the 0.5. But we can leave it just like that, as the calculator gives it to us. This one, I showed you how we can put this in the calculator, but to do it by hand, the square root of 49 divided by the square root of 144. Square root of 49 is 7. Square root of 144 is 12. Right here, we want to just add 144 and 25 together. We get 169, and we can type this in our calculator to get 13. Okay, let's try some more. This is the negative square root of 4. See, the negative's on the outside, so that's just going to be, the square root of 4 is 2, and so we just say negative 2. The negative is on the inside, and you cannot take the square root of a negative number. It's on the inside. So when it's on the inside, that's the problem, okay? So in this case, not a real number. And on number 10, you have the negative square root of negative 169, and again, we have a negative on the inside, so not a real number. So now to take it up a notch, the definition of an nth root. B is the nth root of A if B to the n equals A. So to make sure I mention a couple of things, the n right here is called the index. So like in a square root, like the square root of x, okay? When it's a square root, they don't write the index right there. So if you ever see a radical and it doesn't have a number right here, then it's automatically the square root, okay? But for all the larger roots, you'll see the third root and the fourth root and so forth. So if your index is even, then what you are taking the root of must be a positive number. It must be greater than 0, okay? But if your index is odd, well then it doesn't have to be, you can take, for instance, the cubed root of a negative number, but you can't take the squared root of a negative number. See, 3, the index of a cubed root, would be odd, but the index of a square root would be even. So you cannot take an even root of a negative number, but you can take the odd root of a negative number. So let's try a few examples. Right here we're saying, what can you multiply by itself 3 times to get -8? This in the I can put this in the calculator by saying 3, because 3 is the index. It's the third root of negative 8, so 3, second, and then I'm not going to hit square root, I'm going to hit the x to the root. So whatever is in front of that x right there, that's the root you're taking. So this is the third root. If I were going to put a 4 right here, that would be the fourth root, or 5 right there would be the fifth root. Anyway, so the third root of negative 8, you get negative 2. So that basically means that negative 2 times negative 2 times negative 2 equals negative 8. And that makes sense because a negative times a negative is a positive, but then that positive times another negative gives you that negative 8. And it could also be thought of as negative 2 cubed equals negative 8. But again, the cubed root of negative 8. So our answer for this one is negative 2. So for the fifth root of 243, I'll hit 5 for my index and then press second. And the x the root, okay, which is the caret key right here. But make sure it's the x root and not the square root. Okay. Of 243. And oops, I put 243. And you get 3. On number 13, you have a negative, so that kind of comes down. This is basically saying negative 1 times the fourth root of 81. And the fourth root of 81, we can do that in our calculator, but that is 3, and so that means 3 times 3 times 3 times 3 is 81. Anyway, so the fourth root of 81 was that 3, and now we just had that negative out front, so we'll say negative 1 times 3 is negative 3. Okay, the way I think about number 14, I actually raise negative 2 to the fourth power first, and this is easy to do in your calculator. You just want to hit, you want to open the parentheses and hit negative 2, close the parentheses, and this caret key, it's pointing like a caret, right? Lets you raise to a power. So negative 2 to the fourth is 16. So now, since negative 2 to the fourth is 16, then we replace that negative 2 to the fourth with a 16 underneath the fourth root. So now we can take the fourth root of 16 to get positive 2. Another way to think about it is that the fourth root undoes the power of 4, but since 4 is even, then your answer would have to go into your inside that you were left with if the fourth root and the power of 4 undo each other. Would go in absolute value bars because 4 was even, right? And so the absolute value of negative 2 is 2, which is what we got. Now looking at 15, we can type it into the calculator the same exact way. Or if you were listening to that part I just mentioned, the third root undoes the cube, but see, 3 is odd. And since 3 is odd, when I say that cubed root undoes the cubed, that -7, that inside that you're left with, does not have to go in absolute value bars. But you can do that in the calculator to double check yourself. Okay, so right here we had a cubed root undoing a cube. Right here we had a fourth root undoing a fourth power. And now we have a squared root undoing a square. This is a squared root. The index is 2 because it wasn't written there. And the squared root, now this one you can't put in your calculator, it's a variable. But the same principle applies. The squared root undoes the square. So our answer is the absolute value of D. And we have to put that, again, it's in... It's an even root. It has to go in absolute value bars. And this is the simplified answer. Last time I did absolute value bars, I was able to simplify it further and say that the absolute value of -2 is 2, but I can't take the absolute value of D because D is an unknown. Okay, so now we're getting into some of my favorite stuff. This is the squared root of m to the 6. Remember, this index is 2. The way you take a squared root of a variable and the way you take the square root of a number is very different. Now, last time we had a squared root of D undoing the square, but this time we have a squared root and it's m to the 6th. So what you can do is just say, how many times does 2 go into 6? It goes into there 3 times evenly. So m cubed is our answer. Here's the reasoning behind it. When m to the 6th is m times m times m times m times m times m. And remember, when you multiply something by itself, you're squaring it. So a squared root, you're looking for groups of 2. And there are 3 groups of 2. So that's why it was m cubed. But again, you can use my my trick of, say, how many times does this index go into the power? We're going to use that same trick right here. Really, I mean, this is the square root of s to the 10th times the square root of t to the 8th. You don't have to separate it like that, but I mean, that's really what's happening. So for our final answer, you're trying to say how many times does 2, the 2 that's not there, go into 10? 5 times evenly. And how many times does 2 go into 8? 4 times evenly. So s to the 5th, t to the 4th. Again, just to prove it to you, s to the 10th is s times s times s times s. So s multiplied by itself 10 times, and there are 5 complete groups of 2. And t to the 4th, there are, t to the 8th, there are 4 complete groups of 2. So that's why this is our answer. So we need to regurgitate some information here. The way you take a root of a number and the way you take a root of a variable is different. Okay, you got to think about it differently. I personally like to separate all of them. Okay, so let's do something that we're familiar with. We were just doing variables, so how many times does 3 go into 12? Goes into there 4 times evenly. How many groups of 3 are in 21? There are 7 groups of 3 in 21. Okay, but now the cubed root of -8, we can take the cubed root of a negative. We can't take the even root of a negative, but we can take the cubed root, an odd root of a negative. And the answer right there is -2. And notice we didn't say how many times does 3 go into, we didn't do all of that. I just know that -2 times -2 times -2 is -8. But again, this part you can put in the calculator. And then for the other part, you can say how many times does 3 go into 12. How many times does 3 go into 21?